Hi everyone, my name is Parwinder Singh and I am a student of ACTS Auckland College of Tertiary Studies. I am from October intake. Today we are representing the presentation to the topic number cost planning 2. So these are the topic 1, preliminary cost planning. Second is the measurement and cost analysis, and third one is the whole life cycle costing insights. So is the preliminary cost planning. Present your element cost plan referencing QB cost builder and that IQS elemental analysis. These are the pictures. The first one to the definition to the preliminary cost planning. Cost overview for a 6-story mixed-use building. To accurately plan cost and keep the project within budget, it's essential to select cost benchmark that align with the building's components and their intended functions. Below is the summary of the key benchmark used for the project. First one is the substructure foundation. Due to the challenging ground condition in central Auckland, pile foundation are required. These typically range in cost from $350 to $450 per square meter. For this project, we adopt a mid-range estimate of $400 meter square, which covers excavation, steel reinforcement, formwork, and concrete based on finding from previous geotechnical investigations. The second one is the substructure. This includes the building's primary structural elements such as columns, beams, floors, and roofs. The structure will feature reinforced concrete frames, present concrete floor slabs, and lightweight steel roof. The estimated cost range from $500 to $600 per square meter, with an average rate of 575 meters square used for planning. The third one is internal finishes. These costs are based on the intended use of each area and are calculated per square meter of surface area. Retail spaces are estimated and 1,200 meters square. Residential units at the 1,350 meters square, and office areas at the 1,300 meters square. These estimates accounts for features such as acoustic ceilings, durable flooring for commercial use, and decorative finishes for residential areas. The fourth one is mechanical electrical services. This category covers essential building systems such as heating, ventilation, and air conditioning, electrical, plumbing, and lift installations. For budgeting purposes, these services are typically estimated as a percentage of the total building cost, 20% for residential areas, 15 to 18 for retail and office spaces. Alternatively, average cost for square per meter can be used. HVAC $220, $235 meter square. And the fifth one is external work. External work, this refers to the external works surrounding the building such as landscaping, pathways, and site drainage. Typically benchmark cost as follows: landscaping, driveways, retailing walls, and drainage system. The next slide is the preliminary cost planning. Extra cost contingencies and inflation in the budget. In addition to the main construction cost, the building budget also accounts for additional expenses known as on costs, which typically range from 8% to 12% of the total building cost. These costs cover items such as professional fees, council fees and consents, development charges, site supervision and management. A contingency allowance of 5% to 10% is also included to address unforeseen costs such as design changes, unexpected ground conditions, or minor delays. The exact amount depends on the complexity of the project and components of the design. To exact account for the potential increases in material and labor costs and inflation, allowances is factored in as well based on QE cost builder data and current market rate trends. Next slide. The measurement and cost analysis. The first one is gross floor area. The gross floor area is a gross floor area represents the total area of all indoor spaces within a building measured from the interior surface of the building outer walls. GFA to wall ratio. This ratio assesses the efficiency of the building design by comparing the external wall area to the total floor space. A low ratio typically indicates a building with a more complex shape featuring elements like concerns, balconies or intricate facades. A high ratio suggests a more compact design which is often more cost effective. The next slide. These are the gross profit area. The gross floor area to wall ratio is used to assess the efficiency of the building's layout in terms of its wall surfaces. It is calculated by dividing the total gross floor area by the combined area of both internal partitions and external walls. For the project, digital software was utilized to measure the building plans and the total wall area, including both internal and external walls. With the GFA to wall ratio of 0.68, the design shows a moderate level of complementation. This means the building has a good balance between open and the measurement and cost analysis. The first one is estimated versus actual cost comparison. This section compares the original cost estimates with the actual cost measured later in the project. The task 3 is using average cost rates from QB Cost Builder. These were based on the building's different uses, retail, residential and office, and followed a journal. Measurement task. Using the final building plans, these gave more accurate quantities and prices through the building. Below is the comparison table showing the estimated versus actual cost, followed by the brief explanation of any differences. The next slide is these are the measurement trades. The analysis reveals that all 6 trades exceeded the budget as reflected in the negative percentage. The most significant cost overruns were in external block work and substructure, indicating the initial estimates did not fully account for the scale or complexity of these project components. For instance, the amount of block work may have increased due to additional design features, structural modifications, thicker walls that were not initially considered. Other trades such as windows, doors and floor finishes also went over budget, though the variations were smaller. Next slide. The next slide is measurement and cost analysis. Justify the two highest cost variances and what contributed to the differences. Variance overview, original estimate, SOQ cost, and then variance. And then key reasons for cost overruns, underestimate during plans, and another slide. Design and specification changes. Some structure and fire rated walls ended up being large or thicker than expected. This led to a big increases in the amount of materials needed and therefore higher costs. More accurate digital measurements using Costex software gave precise measurement of wall lengths, heights and the number of blocks. This accurate data showed that some items were missing from the original cost estimates. Item missed in early estimates. The early estimate didn't include important parts like concerns, fires, reinforcement and cavity walls, which added unexpected cost later on. Trade cost comparisons. External block work had minus 18.8844% cost overruns, mostly due to changes in design and material needed. Next slide. Next slide. Whole life cycle costing insights. This section examines the durability of two common building materials, steel roofing systems and reinforced concrete slab flooring. The analysis evaluates these materials in terms of long-term cost, durability and environmental impact, considering their performance over a span of 20 to 50 years based on typical building and maintenance practices in New Zealand. The objective is to assist design making by highlighting the differences between initial construction cost, future maintenance expenses, and construction cost to future maintenance expenses. This comparison addresses both short-term construction costs and the long-term performances and environmental consequences. Next slide. These are the whole contingencies. Another slide. Stainless steel. Stainless steel. Stainless steel roofing is less expensive to install than galvanized steel and easier to install. Additionally, it can be recorded over time and is recyclable, making it is more sustainable choice. In contrast, concrete slab flooring has a higher upfront cost but can last up to 50 years, providing strong long-term value. However, it cannot be refused once it reaches the end of its lifespan. In terms of maintenance steel roofing requires more frequent recoating, while concrete slabs needed less regular upkeep, though they still require attention over time. Overall, steel considered the preferred choice due to its lower environmental impact, recyclability and ease of maintenance in comparison. The next slide. Whole life cycle costing insights. The analysis in task 3.1 concluded that steel roofing is the most cost-effective option, offering the best value to and lowest long-term expenses. Over time, steel roofing saved 3,625 compared to CSA concrete slabs. Additionally, steel roofing has a lower environmental impact and is easier to recycle. Although steel roofing requires periodic maintenance, its lightweight, ease to installation and sustainability make it well suited for Green Star, NZ and other building standards. Another slide. Green life conclusion. Whole life costing insight. Green roofs and rooftop garden systems involve layering soil and vegetation on building rooftops, delivering multiple advantages such as improved thermal insulation, effective stormwater water management, and enhanced air quality. These systems also boost building a visual appeal and support occupant well-being by offering areas for leisure and relaxation. Another slide. The last one is conclusion. In conclusion, the assessment of various building materials and sustainable systems, highlighting the importance of considering both cost and environmental impact throughout building's life cycle. Steel reinforcing roofing emerges as the most cost-effective and environmentally friendly choice, providing long-term savings, lower environmental footprint, and better recyclability compared to concrete slabs. Additionally, the incorporation of green roofs and rooftop gardens offer significantly benefits, including improved insulation, stormwater management, and enhanced biodiversity. These solutions align with sustainability objectives and adhere to building standards, promoting more responsible and community-focused urban development. And then these are the references. And thank you.
Okay, thank you, Parwinder. I have some question to you.
Yeah.
What is the preliminary cost plan?
Preliminary cost plan is before making the project. to how much cost and quantities to rough budget project. Is it the preliminary estimate?
What is the QB cost builder?
QB cost builder, is it the cost builder?
Is provided the what about is providing cost data?
Cost
Cost data according to location and the
And
type of the
then-
projects. Okay, what is contingency?
is it is allow the unexpected cost of the project.
Some allowance is made for the unexpected cost.
Unexpected cost of the project.
The benchmark. What is benchmark?
Benchmark in the construction involves comparing projects' performance, processes and costs against industry standards or similar projects or to identify areas,
Okay, similar given project
areas
that we
to
identify
areas
for
for improvement. Yes.
Right. What is the whole life cycle cost?
The whole life GFA ratio measures the proportion of wall area to the gross floor area impacting building energy efficiency and design.
No, that is you are going to ask for the wall to floor ratio. Okay, I'm asking whole life cycle cost.
Whole life cycle
Cost.
whole cost estimation.
What is whole life cycle cost? I'm asking.
Whole life cycle cost.
Yes.
Whole life cycle.
Take the one element and explain to.
Element.
You have to purchase one. That means the manufacturing cost is there. Then you use for the
Solar
construction.
panel.
No. I'm asking the whole life cycle cost of the material. What is
Whole,
it?
whole life.
First you have the initial cost and the construction cost.
Initial cost,
then
substructure
maintenance
cost, and
maintenance cost and
maintenance
the
cost and
disposal cost.
Disposal.
Altogether we call the whole life cycle cost. Okay, what are sustainable measures you've taken in your scenario?
Solar panel.
Solar panel.
Reinforcement water.
Rain,
Rains water
rain-
harvesting.
Rainwater harvesting. Okay, it's fine. Okay, thank you.
Thank you.